All right, guys, you guys ready? All right, here we go. So note 6, this is kind of like a review for you guys. So a lot of these concepts are you guys have already talked about. Remember that for something to be continuous, for you to be continuous by the definition, the limit as x approaches c from the left-hand side of some function better equal the limit as x approaches c from the right-hand side of that same function, which obviously that means that the limit of x approaches c from the left and the right has to be the same, and that has to equal f of c. All three of those conditions must be the same. I guess you could also just look at this one. As x approaches c of some function, it has to equal f of c. So that means that I can't have any holes, it can't have infinite discontinuities, stuff like that. Cool or not cool? So yeah, so it's pretty straightforward, guys. It's nothing crazy. So here's example 1. I have a piecewise function. And let's see, what two limits must be equal for g of x to be continuous at -2? Well, the limit from the left better equal the limit from the right. So there it is. So those two functions better be the same. So limit as x approaches 2, or it says -2. I always do that. -2 from the left. So if I approach from the left, it's kx squared plus m. And that better equal the limit as x approaches -2 from the right, which is 4x plus 1. Are we okay? Nothing crazy, right? So if I plug in the -2, guys, well, they're not asking for it, but I'm going to need it eventually, I'm sure. So -2 squared is 4. So here's my first equation that I'm going to get. 4k plus m better equal -8 plus 1, -7. Does everyone see where I got that expression from? All I did was I plugged in a -2 into my kx squared plus m. So -2 squared was 4, and 4 times k is 4k. And then I plugged in a -2 into the 4x plus 1. Cool or not cool? Thunder? Okay. Let's go to the next one. It says, what two limits must be equal for g of x to be continuous at 3? I'm going to change my colors. Then the one in the middle, as I approach 3, that's approaching 3 from the left-hand side, better equal as you approach 3 from the right-hand side. So I'm going to write limit as x approaches 3 from the left-hand side. If I approach from the left-hand side, it's at 4x plus 1. And it better equal the limit as x approaches 3 from the right-hand side of kx minus m. If I solve for those two, let's see. 4 times 3 is 12. 12 plus 1 is 13. So 13 equals 3k minus m. Have I confused anyone? Is everyone okay? Okay. So it says determine the values of m and k so that the function is continuous everywhere. Guys, you're done. All you got to do, you just turn this into algebra. Of course, you got to make sure that there's an equal sign on both, and there is. There's an equal sign right there and an equal sign right here. So here we go. Equation number 1 is 4k plus m equals -7. And equation number 2, and I'm going to write it like this, 3k minus m equals 13. If you add those two suckers, the m, well, I shouldn't call them suckers, I'm sorry. If you add those two equations, the m cancels out. Do you guys see that? So I'm going to add them. 4 plus 3, 4, 5, 6, 7. So that's a 7k, and then the m's cancel out, equals the difference between 7 and 13, 7, 8, 9, 10, 11, 12, 13, 6. Let me know if I made any mistakes, but the 13 is larger than the -7, so it's positive. So the k is equal to 6/7. Are we okay? Now I want to find out what m is. I can use whatever equation I want. I'm going to use the equation number 1. So let me see. 4 times 6/7 plus m equals -7. So 4 times 6, 6, 12, 24. So 24 over 7 plus m equals -7. I'm going to move this dude to the right. M equals -7 minus 24 over 7. Catch up, guys. And now all I'm going to do is get a common denominator. So m equals -49 over 7 minus 24 over 7. 49, 59, 69, and then 4, so 73. -73 over 7. I know some of you are faster than me when it comes to adding. I do it in pieces, as you just saw. How do we feel? I know, guys, it's late. It's last period of the day. You guys are all tired. You guys have been working. Who knows what time you guys got out of work yesterday, and who knows how many hours of sleep you got. But here we go. Yeah, if you can help it, guys, try not to. Mondays is the hardest days to work, so maybe work Friday, Saturdays. If you guys have jobs. How many of you guys have jobs? Just 3 of you? Oh. Sorry, guys. You're going to be working all your life, so... Well, if you choose a career, then you don't really feel like you're working, right? Because you're having a good time. Like, look at me. I'm doing math life every day. I'm having a blast. So, okay. Here you go. Example 2. This one's coming from UH. Oh, by the way, UH has been cleared. Your accounts are back. If you log in, you'll see all my accounts there again. So, I don't know who prayed really hard for UH to be down, because you got your wish for a day, but it's back on. All right, here we go. Given that f of x equals the square root of x plus 4 minus 3 over x minus 5, define the function f of x at 5 so that it becomes continuous at 5. Okay, they're telling me that this function is possible to be continuous, maybe. Remember, guys, the only way that you can be continuous is if this has a hole. By the way, I just drew a random graph. I'm not saying this graph looks anything like it. I just drew something. If this graph looks like this, you can't be continuous. It's a jump. Or if this graph looks like, let's see, and then you have a vertical asymptote. If this graph looks like this at 5, then you can't be continuous. You have an infinite discontinuity. So how are we going to figure out what type of discontinuity I have? I'm going to do the limit. If I have a limit from the left and the right, that means I have a hole. Does that make sense, guys? Okay, because if you have a limit, that means that I converge at a value, but you're not defined at x equals 5 because you can't divide by 0. Cool? All right, here we go. So I'm going to write limit as x approaches 5. That's what I'm trying to figure out. I'm trying to figure out if this has a limit of the square root of x plus 4 minus 3 over x minus 5. Okay. If you've done at least 40, 50 problems of limits, which most of you I think are there already, unless you haven't been doing your homework. A lot of you probably are starting to get intuition, math intuition. So you've done enough that you're feeling like, okay, what do I need to multiply this so I can make this, so I can find out, so I can do algebraic manipulation to find out if this has a limit? Yeah, the conjugate of the numerator. That's what's making it tough. Guys, the only way you're going to get there is to practice. If you do no practice, when you see this question, you're going to be like, well, I don't know what to do, because you haven't had enough experiences yet. So guys, please practice, practice, practice. All right, here we go. When I do that, I'm going to go limit as x approaches 5, because I haven't figured out that limit yet, so you got to keep writing limit. This is kind of like the difference of squares in the numerator, if that makes sense. So square root times square root, the square roots go away. X plus 4. Negative 3 times positive 3, that's a minus 9. Over in the bottom, in the denominator, do not distribute. Leave it like this. And now we're ready. We're almost. 4 minus 9 is 5. I'm going to write the word limit one more time. And I'm going to have x minus 5 over x minus 5, close, open, square root of x plus 4 plus 3, close. What is going to cancel? Yeah, the x minus 5 cancel. Bam, out. Now I can do direct substitution. 5 plus 4 is 9. The square root of 9 is 3, and 3 plus 3 is? Excuse me, that was a hiccup. 6. So 1 6. Make sure that 6 is in the denominator. Yay or nay? Yay. So what do you got to make for it to be continuous if f of 5 equals 1 6? Now I prefer that you do a piecewise function. Chav, what are you talking about? I prefer that you do this, but it's okay if you don't. Square root of x plus 4 minus 3 over x minus 5, and then 1 6. As long this one you cannot equal 5, and in this one, if you equal 5, when x equals 5, it'll be 1 6. So there it is, guys. There's a lot of heat coming out of here, and I feel weird with all the caffeine in me. Sorry, miss. Thank you. Okay. Here we go, guys. Ready for the next one? Oh. Cheers. Sometimes I see you guys, and I don't know what you're thinking, because sometimes you're either like this, you're either like, and I can't tell if you're following along and bored, or if you're just like spacing out, or if like you're really getting it. So, so if you see me look at you and then look away, I'm not. Okay, I'll stop. Okay, intermediate value theorem. Have we covered this already before or no? No? Okay, it's very simple, I think. Let's see, do you understand it? But if you read this little thing here, the intermediate value theorem for continuous functions. A function that is continuous on a closed interval a to b takes on every value between f of a and f of b. In other words, if y naught is between f of a and f of b, then y naught equals f of c for some c in ab. Did all that make sense to you? Okay, relax. All it means is this. You see this y value at a? You see this y value at b? All it's saying is that you take up all these. Let me go ahead and change it to sky blue. All these y values in sky blue. As long as you're continuous, you have to be continuous, guys. The intermediate value theorem guarantees that you take up all those y values. Obviously, in this graph, you went a little bit above and a little bit below. We do not know if we go above or below, but we guarantee that everything in between definitely hits. Let me give you a real-life example that everyone can relate. Have you guys ever driven in a vehicle or been a passenger in a vehicle? Yeah, of course. Yeah, we're in 2024. Come on, like we're not cavemen. We're not walking everywhere. Okay. Oh, it's coming back on. I just need to give it my face. Like, how do I type in my pen? Oh, I got a keyboard. All right, guys. I don't know if it's recording this, but if it is, I guess we'll find out. All right, here we go. Let me give you a real life example. If you're driving, and when you look down at your speedometer or odometer, it says 55 miles per hour. Okay, you know what? I'm doing this one exactly. So I'm doing example 3 right now. You look down at your odometer and it says 55 miles per hour. Did you at any time travel 52 miles an hour? Yeah, the only way to get to 55 is if you hit 52. The only way. Velocity is a continuous function. It just doesn't go from 10 miles per hour to 30 miles per hour immediately. You have to go 10, 11, 12, 13. Like, does that make sense? But if you look down on your odometer, does the intermediate value theorem guarantee that you are going 70 miles an hour when you see that in your odometer that it says 55? Maybe you hit 70, but it doesn't guarantee it. Does that make sense? So what does the intermediate value theorem say? As long as you're continuous, that you hit every value. Let me give you another example. So let's say Maddie here is a point on a graph, and you are 2, 5. Okay, remember your x value, 2, and then your y value is 5. You're above the x-axis. And let's say, who wants to be the other value? Let's say Hernandez is 5, -3. So you're 5, -3. What were you? Okay, and let's say that you have a graph that goes through both of those points, continuous. You must be continuous. Did I cross the x-axis? What do you guys think? Did I cross the x-axis? Look, she was, what were you, Maddie? So she was 2, 5. What were you, Hernandez? 5, -3. So she's 2, 5. She's 5, -3. Did I cross the x-axis? You must. If you're continuous, there's no way you can go from a positive y value to a negative unless you cross the x-axis. Does that make sense? That's the intermediate value theorem, guys. Now, how many times did it cross? You don't know, but you crossed at least once. Cool? Cool. So look, check it out. So we already did example 3, kind of. We just didn't talk about that scenario, but we did it. Example 4. And by the way, don't have my bad habits. Avoid, let me make sure that this is being recorded. Yeah, it is. I wonder how it handled that whole time that it messed up and all that. Avoid acronyms. That is a bad habit of mine. Say intermediate value theorem. That is a bad habit of mine. Don't have my bad habits. I just can't help it when I'm typing. Are we okay? Check it out. Can the intermediate value theorem be used to show that there is a solution for the equation f of x equals 0? That means I cross the x-axis, or I hit the x-axis at least, on the interval 1 to 2. These are x values. X equals 1 to x equals 2. If f of x equals this, give an explanation why. Okay, you don't have a calculator. We're just going to talk about it like this, guys. Here we go. F of 1 equals 3 times 1 cubed minus 5 times 1 squared plus 1 minus 3. 3 minus 5 is negative 2 plus 1 is negative 1. Negative 1 minus 3 is negative 4. So f of 1 at the moment is negative 4. So this is how you say negative, less than 0. So negative 4 is less than 0. Are we okay? All right, here we go. I'm going to write f of 2. F of 2 equals 3 times 2 to the third minus 5 times 2 squared plus 2 minus 3. Child, I can't do that without a calculator. Yeah, you can. 3 times 2 to the third, that's 8. Minus 5 times 2 squared, that's 4. And then 2 minus 3, that's minus 1. Let's see what this is. 3 times 8. 8, 16, 24. So 24 minus 20 minus 1. Okay, 24 minus 20 is 4. And 4 minus 1 is 3. So f of 2 is 3. And this is positive. And I'll wait for you guys to catch up. I know that f of x is continuous on the interval 1 to 2. Oh, that's for attendance. Oh, yeah. Okay. All right, here we go. F of 1 was negative. F of 2 is positive. Did I cross the x-axis? Yes. Here's how you're going to say it. You're going to say, since f of x is continuous, comma, and then what would I say next? You know what? Make that. Can I do a semicolon? Is that wrong English? It is wrong? Okay. Since f of x is continuous and, comma, let me see. Okay, all right. Too bad. It's not proper English, but we're going to be fine. F of 1 is negative and f of 2 is positive, comma, hence, comma, again, there must be an x value such that f of x equals 0 on what interval? On this interval from 1 to 2. And then I'm going to put comma and then put intermediate value theorem. You can probably get away with not saying it. And then read it and see if it made sense. Since f of x is continuous, f of 1 is negative and f of 2 is positive. Hence, there must be an x value such that f of x equals 0 between 1 and 2, comma, intermediate value theorem. Does that make sense? Yeah, it makes sense to me. One's negative, one's positive. I have to cross the x-axis. Yay or nay, guys? Okay. Here we go. Okay. All right, guys. This is a true story. It went into effect last year, I think, but I put still it's not a new law anymore. Or 2 years ago, maybe. There's a law that goes into effect this August, or last August, or 2 August ago, I don't know. How do I pronounce that? Atchafalaya? Did I say that right? Atchafalaya Basin Bridge. Has anyone ever heard of that bridge? True story, guys. Tell your parents about this. The bridge is 18 miles long and it's part of I-10. The new law allows the use of cameras to support issuing a ticket based on how fast it takes a vehicle to get from one end of the bridge to the other end. drivers who cross a bridge in less than 18 minutes would receive a speeding ticket in the mail. Guys, I think this is true, and this happens very often. If you are in a toll road that takes a time stamp of when you enter and then takes another time stamp of when you exit, they can give you a ticket if you pass it within a certain time. Why? Why can't they give you a ticket? They know, yeah, they can calculate your average speed. They know when you enter, they know when you exit, they know how long it took, and they can find out your average speed. Look, tell me what the speed limit is here, letter A. They tell me if I pass, the bridge is 18 miles long. If I pass this bridge in faster than 18 minutes, I get a speeding ticket. What's my speed limit? 60. Yeah. How'd you get 60 miles per hour? Because the bridge is 18 minutes, 60 miles per hour. In case you're wondering, how do they do it? 18 minutes or 18 miles, and you do 18 miles in 18 minutes. And I don't want miles per minute. I want miles per hour, right? 60 minutes in 1 hour. And then look, minutes cancel out, and you get 60 miles per hour. Bless you squared. Or was it 18? Look, 18 times 60 divided by 18. The 18 cancel out, guys. You get 60 miles per hour. Do you guys see that? Or 18 divided by 18 is 1. And I wish I had a button that I can push with pyrotechnics. Fire everywhere. Wake you guys all up. Does that make sense? Cool or not cool? Okay. And then we're not going to do this, but it says, use the intermediate value theorem to explain, is this law fair and just for all drivers? And then I said, make a 1-minute speech to city council, determine your justification. All right, guys. Again, if you ever hit a toll road, maybe in California, or you hit a toll road in Houston, guys, if you have a heavy foot, I would take a pit stop, go stop at a gas station, because they can see when you're in the toll road, and they can see when you're out of the toll road. And if you pass it super fast, if you have a heavy foot and you like to speed, you're gonna get a ticket. If the law permits and they allow you to, because that's evidence that you definitely sped if you go faster than a certain. You know what I mean? Okay. All right, guys. So there it is. Hopefully we have an understanding for the intermediate value theorem. You must be continuous. You must be continuous for you to use that intermediate value theorem. Cool or not cool? Okay. And then these are just questions from UH Quiz 3 and 4, guys. Well, actually, this one's pretty good because this one says, give the value a and b for the function f of x to be continuous on both x equals 1 and x equals 6. Okay, so again, same thing. At x equals 1, these two better be the same. So I'm going to write at x equals 1, a times 1 is a, so a minus b better equal 15. I'm going to call that equation 1. Equation 2, at x equals 6, I'm going to change the color. These two right here better be the same. So at x equals 6, what's 15 times 6? 15, 30, 60, 70, 90. 90 equals 36b minus a. That's equation 2. Does everyone know where the equation 2 came from? I plugged in the 6 in there because if I approach from the left, the 90, 15 times 6, if I approach from the right, it's bx squared minus a, so the 36b minus a. Are we okay? All right, now you can do whatever algebra you want. I'm gonna take this one, and I'm gonna say, what am I gonna say? I'm gonna say that a equals 15 plus b, because I just moved the b to the other side. See? So I'm gonna take this, 15 equals a plus b, and I'm gonna put it in there for that a, guys. So 90 equals 36b minus parenthesis 15 plus b. Look, you're done with calculus. You're just doing algebra now. Now it's just algebra, guys. So distribute. 90 equals 36b minus 15 minus b. Sorry, guys. Let me clear that. And then let's see, what's that? Plus 15, so 90, 105 equals 35b. And then divide by 35, and then we get 30, 60, 90, 5, 10, 15, 90, 105. Yep. B equals 3. Now that I know, and I'll slow down. Now that I know that b equals 3, I'm going to plug that value in right there. Sorry. A equals 15 plus 3. 15, 16, 17, 18. 18. How do we feel, guys? ¿Cómo te sientes? How do you sit? I'm sorry, that was a really bad joke. ¿Cómo te sientes? That's how, okay. Like, it could also be how do you feel, right? Like, okay, all right. YouTube, don't give me a thumbs down for that, please. Okay, all right, guys. Last ones. These are just getting ready to work with inequalities and all that good stuff. All right, so look what this says. Solve the inequality. This is coming from UH quiz, so it's not really a limit or continuity or any type of that issue, but we're going to get to these. We're going to figure out these signs. Solve the inequality for x, give him that. So what this wants you to do, it wants you to find the x values where this is true. Find the x values where this statement is true. Don't worry, guys, we're almost done. All right, so how do I find the statement values where this statement is true? I'm going to find something called critical numbers, and I know we're not there yet where the derivative is 0 or undefined. You know what? I don't want to call it critical. Find what? Find where statement function equals 0. That's the first step. Chav, why are you doing that? Because I change signs when I cross the x-axis. I go from positive to negative when you cross the x-axis. The Chav, what are you talking about? If I go like this, at x equals 3, I'm going to call that 3. I'm just making this up. This curve changes from positive to negative at 3. Do you guys see that? So that's why, and what does this mean? This means I want the left side to be positive. So here we go, guys. X equals 5 is one of the answers. How did I get that? 5 minus 5 is 0. 0 times anything is 0. What's another answer? Well, what times what is 28? 4 times what is 28? That's another answer. Do you guys see what I did? I just said 28 minus 4x equal to 0. All right. I call this a railroad track, so you guys have known me for a long time now, and you guys have known that I've called this a railroad track, but the correct word, I think it was Dr. George that told me, don't call it a railroad track. It's called a sign chart. So tell me what that name is called, what this is called? A sign chart. You can call it railroad tracks with me, but if you're talking to a professor, maybe tell the professor, yeah, here's my sign chart. It's called a sign chart. Okay, all I'm going to do is I'm going to choose values. I do not care whether it's positive or, I do not care the number. All I care about is whether it's positive or negative. And what am I going to do? I'm going to plug it in here. I don't care about that x minus 5 squared because that's always positive. Always positive. So all I'm going to do is pick numbers and I'm going to plug it into this and see if it's positive or negative. Give me a number to the left of 5. 4. What's 4 times 4? 28 minus 16. Positive or negative? Does that make that statement true? Yes. That's going to be part of your interval. Don't worry. I guess I shouldn't say that until once I finish. Give me a number between 5 and 7. So what's 4 times 6? 28 minus 24. Is that still positive or negative? Positive. Put a positive symbol. Give me a number bigger than 7. Did I hear 10? 8, 10. 4 times 10. 28 minus 40? Negative. This wants the left side to be bigger than the right side. So what this means is I want my expression to be positive. That's what it means. Where's the expression positive? From negative infinity all the way to, well, be careful. Right at 5 and right at 7, it's 0. Is there an equal sign in the bottom of that? No, so then I got to break it up. From negative infinity to, I don't know, 5 union, or close parenthesis, union, open parenthesis, from 5 to 7. Close it. Does that make sense, guys? Okay. Go to the next one. Don't worry, there's the last one, I believe, and then we're going to set you free. Not that you're not free. It is America. We're always free. We do what we want. Okay. Here we go. I hope I didn't offend anyone. Did I offend anyone? No. Okay. All right. I want to know where this is 0 or undefined. It's 0 when x equals 5. Do you guys see that? 2 times 5 is 10. And I'm undefined when x equals 2, because 2 minus 2 is 0. You can't divide by 0. And when x equals 8. You got those 3 numbers. All right, here we go, guys. My sign chart, my railroad track. 2, 5, 8. I'm going to choose a number to the left of 2, like 0. If I choose 0, I get a negative 10 in the denominator. Put that in your thought. Negative in the top. Negative in the denominator. If I put a 0 in the denominator, 0 in the numerator. Sorry, negative in the numerator. If I pick a 0 and I put it in the denominator, I get a negative times a negative. Negative times a negative is a what? Positive. So what is negative divided by a positive? Put a negative. Give me a number between 2 and 5. 3. 2 times 3 is 6. 6 minus 10. What is that? Positive or negative? Negative. Put that in your thought, or you can put a little symbol if you're tend to forget, especially if you're tired. You're not going to be able to remember. Okay, plug in a 3. 3 minus 2. Positive or negative? 3 minus 8. Positive or negative? Positive times the negative. So what did I have on the top? Negative. So negative divided by negative. Positive. Put a plus symbol. Give me a number between 5 and 8. 6. 2 times 6 is 12. 12 minus 10. Positive or negative? Positive. So you got a positive on the top. 6 minus 2. Positive or negative? Positive. 6 minus 8. Positive or negative? Positive divided by negative. Negative. And then finally, a number bigger than 8, like 10. Positive on the top. Positive times positive on the bottom. You're going to get positive all around. What this says, I want my statement to be negative, because that's what it says. I want that statement to be less than 0. So it is true between negative infinity and 2, union from what to what? 5 to 8. And there it is. Make sure parentheses on everything, and we're done. How do we feel? Do we feel good? Okay, so let me stop this. Hey, Ms. Garcia, your classmates say what's up. Yeah, you heard them. Say what's up. So there they are. They're missing you, and come back whenever you get a chance. We can do some math life. But continue. If you're sick, continue staying home. All right, later. Not later. You're gonna continue watching my videos, so continue watching. Okay. Here we go, guys. Look at this. So continuing. Let's do. Okay. It looks tough. You're like, oh my God, what am I doing here? So look what it says. It says, use the definition of continuity to determine whether the function f of f graph below is continuous at -5. I go to -5, and look, it's definitely continuous. Definitely. Limit as approaches the left, limit as approaches the right. And look, there's no hole there. It's just nice curve. So I'm going to say limit as approaches -5 is 7. So I put 7. Limit as approaches -5 from the right is also 7. And it can be determined that the limit exists and is equal to 7. Furthermore, it can be seen that f of -5 is also 7 because, look, it's a nice smooth curve. I don't think I'm making a mistake. Let me make sure it's 7. Yep. Therefore, it can be stated that the function f of x is continuous at x equals 5 because the limit is as x approaches 5 is equal to f of -5. See? Is equal. So everything checks out. I submit, and voila. Pretty straightforward. Let's see. See, it even does a little animation for you. Let's see. I want to do one that's tough. So let me see if we can do one that's tough. Yeah, those are. No. I want to see one where they block. What? I thought it was this one. Okay. Okay, this one. Okay, look at this. Look how they're blocking it. Look what it says. Go from what? Let's see. Let's read the problem. The function f of x has a domain of -5 to 9 and is plotted below such that the portion of the graph on interval 3 to 0 is hidden from view. Okay, before I continue, did they mention anything about continuity? Nothing. Nothing. They didn't share nothing. I'm sorry, guys. I'm trying to hide myself up. They didn't share anything. So they don't tell me anything about continuity. Okay, let's continue. Given that f of -3 equals 2 and f of 0 equals 6, determine what conclusions can be drawn based on the intermediate value theorem of -3 to 0. You can't use it. They don't tell you that you're continuous, so let's see what it says. Since the function f of x, okay, they don't tell you that you're not continuous, but they don't tell you that you're continuous. So which one am I going to choose? Not necessarily, because it may, I don't know, they didn't tell you, on its domain, the intermediate value theorem cannot be applied. Therefore, let's see, there may exist, we don't know, because you don't want to say does not, because that means like it does not exist, period. There may exist a value C on the interval, let's see, what's the interval? Negative 3 to 0. So negative 3 to 0, where f of c equals 5. Maybe, maybe not, because it depends if whether it's continuous or not. Submit. I don't see anything wrong. And there it is. See? They don't tell you how it looks, guys. So let's do another one, because these are the ones that can be tricky. Look at this one. I love it now. Not that it's McDonald's or anything. I'm loving it, but you know. The function f of x is continuous. Now they tell you that you're continuous. They're telling you continuous between negative 9 and 9 and is plotted below such that the portion of the graph on the interval negative 1 to 5 is hidden from view. Given that f of negative 1 is 6 and f of 5 is 4, determine what conclusions can be drawn based on the intermediate value theorem. Okay, guys, they're already telling you that you're continuous. So check it out. Since the function f of x is continuous on its domain, the intermediate value theorem can be applied on the interval, okay, and states that for any value k, so if you're wondering, what's k? K is y values. So let's see, you always put the smaller value first. This value is the smaller y value, so I'm going to put 4 here. And this is a bigger y value, so I'm going to put 6 here. Those are y values. See, because it says k, and it says f of c equals k. There is the value c, and where's c from? From negative 1. So negative 1 all the way to 5. So I put 5 here, such that f of c equals k. All right, must there exist a value c on the interval negative 1 to 5, where f of c equals 5? Well, let's see. My y value, I hit all my values between 4 and 6. Intermediate value theorem applies. You can be 5. 5 is possible. Do you guys see that? But what if they would have told you 7? Would 7 be possible? No, but you're not going to say it's not. You're just going to say maybe you hit it, maybe you don't. But intermediate value theorem does not apply because it only applies for 4 to 6. That makes sense, guys? Okay, so anyways, must there exist a value c on the interval negative 1 to 5 where f of c equals 5? Yes, there exists. There exists a value c on the interval negative 1 to 5 where f of c equals 5 by intermediate value theorem. That's what the intermediate value theorem says. Submit. Bam. See? So read it carefully. See if you're continuous or not. We just did the trickiest problems that can probably throw at you. And that's it. So there you go, guys. All right, we're done.